Okay, so in this video, I'm going to show the answers and solutions to the number 4 of assessment 1 on functions and graphs. Okay, and these are all in type 1. Okay, let's start with letter A. So you are asked to find the domain of f of x equals 3x plus 5. Okay, if you remember what I said during this session, when we identify the domain and range of functions, we have to take a look at the type of function that we have. A 3x plus 5 is a linear function which follows y equals mx plus b. Now, any linear function following y equals mx plus b, the domain is always the set of real numbers, because you can always put any x on the equation and you can always get a value y. Okay, there is no restriction for x. So the domain is the set of all real numbers, no restrictions. Okay, at the same time, the range, okay, so I put any x, okay, this is a linear function, so it follows a line. A line goes infinitely downward and also infinitely upward, or maybe the other type of line inclined this way. So these lines are going infinitely upwards and downwards. So basically you're covering all the values of y. Same with the x. So your range will be the set of real numbers. And again, that is always the case for any equation of the form y equals mx plus b. A linear function will have this domain and range if the linear function is of the form mx plus b. Okay, so the next time you see like f of x is equal to 4x, make this 1000. So focus on the structure. This is a linear function. Domain is x, such as x is a real number or all real numbers, and same with the range, it's all real numbers. That's it. Okay, so that should not be confusing. Okay, let's go to another function. The second one that I gave, so that's b. F of x is equal to x plus 1 squared minus 2. So again, you have to look at the structure of the equation. This is an x squared. An x squared equation is or has a graph like this, and we call this parabola. Okay, so it could be this one, the first case, or it could be this one. Okay, the only difference of these two is that when your x squared has a positive sign, it follows this orientation, and if your x squared is a negative x squared, the parabola tends to go in this direction and it's downward. Okay, so knowing that, knowing the graph of the parabola, it should help you to find the domain and the range. So the domain, as we can see from the graph, so although the graph is going up, it's also going to the left infinitely, it's also going to the right infinitely. So if you consider the x that this graph will cover, then it's clear that we can cover all the x. So x can be any real number. And again, I said in the class during the session that when you have a quadratic equation, a parabola, the domain is always a set of real numbers. That's it, period. Okay, there's no restrictions. Okay, that the domain is the set of all real numbers. That's it. Now, for the range, okay, again you can base the range on the graph. Case 1, it cannot go lower this point. Case 2, it cannot go higher than this point. Now, the good thing about quadratic equation, especially if they are written in this form, is that this number is actually either the lowest or the highest y value. Okay? Now, since this is a positive x plus 1 squared, so the graph is following this orientation. So the value of y is always bigger than or equal to that number, and that number is -2. So the range should be y, element of this set of real numbers, but y should be greater than or equal to -2. And if you want to have a precise, reason why this is greater than or equal to -2, I hope you remember how to graph quadratic equation of this form. It came from f of x equals x squared, a parabola at 0, 0. And then there's a movement. A plus 1 means 1 unit to the left, and then a -2 means 2 units down. So the parabola is now in this location. And again, talking about the range, there's always a value of y from this point up, okay, but no values of y below that number. That is why it's always greater than or equal to that number, and in this case it's -2. Okay, let's try letter C. Okay, for letter C, I gave you this function. It's a rational function. It's a fractional function. And whenever we speak of fractional or fractions, the denominator is always to be considered. The denominator cannot be 0. Otherwise, the fraction will be undefined. So if I have to find the domain of this function, so that means it can be any number except for the number that will make the denominator 0. And in this case, it's 4. Okay? Because this will be 0 when x is 4. So if I say this is x minus 5, then x cannot be 5. If I say x plus 1, then x cannot be -1. Okay? So focus on the denominator. Now the range, this is a special case. Special case will always give you like a single answer. It's always like this, even if I change the numbers like x minus 4, x minus 5, x plus 3, and so on. So this is the range. So y, again, y can be any number. However, since this number cannot be 0, we cannot expect this value. It's like 1 divided by any non-zero number will always be a non-zero number. So there is no way that you could get a 0 value. Now even if the denominator is 0, because 1 over 0 is undefined, so you can never get the y equal to 0. Okay? So that's the domain and the range of y equals 1 over x minus 4. Letter D. Okay, I gave you f of x equals the square root of x plus 3. Okay, so for radical functions, this is a square root. So this is an example of a radical function. Square roots, like fractions, there are restrictions for the value inside the symbol. So to get the domain, so again, it can be any number, but you can only get greater than or equal to negative 3. So how did I get this? Note, x plus 3 should always be greater than or equal to 0, otherwise the x plus 3 will become negative. So when you solve this, this is x greater than or equal to negative 3. That is where we got this. Okay? What about the range? So it can be any number, however y can only be greater than or equal to 0. How? This is a square root, so you could get the square root of any positive number, so you're expecting a positive number. Now, can you expect it to be a 0? Yes. When x is negative 3, negative 3 plus 3 is 0, and the square root of 3 is 0. But you can never get a negative value from this unless it says negative square root of x plus 3. And that would mean y is always less than or equal to 0. But that's a different equation. Okay, so it's a positive square root. The value is always positive, and it can be 0 or any number above 0. So that's letter D. Okay, letter E. So I have f of x is equal to the absolute value of x minus 10 plus 2. This is like the quadratic equation. If you want to find the domain and the range, base it from the idea, you have to ask yourself, am I allowed to put any x here? Definitely, yes. So it can be any real number. What about the y? Okay, you can get the range by looking at the graph. The absolute value is always a v-shaped graph. So if we consider f of x equals the absolute value of x, a v-shaped graph located at 0, 0 as the lowest point. So if I have to translate this or move it, so x minus 10 plus 2, this means 10 units to the right and then 2 units up. So let's say this is already at 10, so you're moving 10 units to the right, and then you have to move up by 2 units. So since the function x minus 10, or absolute value of x minus 10 plus 2 came from the absolute value of x, so it should have a graph following the graph of square root of x, absolute value of x. So as we can see that the graph can only have a value from 2 up. Okay, so now y is any real number, but y can only be greater than or equal to 2. And if you take a look at your equation, this is already telling you what number should you consider in the range. Okay, so that's how you find the domain and range of different types of equations. And each item actually is an example of a type of a function. Like the first one is a linear, the second is quadratic, the third one is a rational or fractional, the fourth is a radical function, and then the last one is an absolute value function. And getting the domain and range of functions that are similar to these 5 functions will be the same. Okay, so make sure that you study how to get the domain and range of each type of function. Okay, so I think that would be it. So I hope this video was able to help you in understanding how to find the domain and range of certain functions. Okay, that's it.